Hello students, welcome to Mathematics Point. Today we will learn a very important question of chapter 1, real numbers of class 10, that is, prove that square root of 2 is an irrational number. So let us start now. So we want to prove that square root of 2 is an irrational number. We will prove it with the help of contradiction method. So how? We will assume that let square root of 2 is a rational number. Rational number. Now, what is a rational number? A rational number is a number which can be written in the form of P over Q. Therefore, I can write square root of 2 in the form of P over Q, where P and Q are co-primes. They are co-primes and Q is not equal to 0. So you must also know what are the co-prime numbers. So what are co-primes? Two numbers are said to be co-prime if their only common factor is 1. Right? So two numbers are said to be co-primes if their only common factor is 1. That is, I'm giving you an example. Say 5 and 6. 5 and 6 are co-prime numbers because both are divisible by only 1. 1 is the only common factor of 5 and 6. Now, so as we said that P and Q are co-primes, it means the only common factor of P and Q will also be equal to 1. Right? So let us proceed further. So when we cross multiply, we will be getting P is equal to square root of 2 into Q. Now I am doing what? Squaring both sides. Squaring both sides. So when I do squaring both sides, I will be getting P square is equal to the square of square root of 2 is 2. So that is equal to 2Q square. Now, it is very important to understand this point. When I say P square is equal to 2 into Q square, it means I can say that 2 is a factor of P square. How? Very simple. I am telling you with the help of an example. Suppose if I write 10 is equal to 2 multiply 5, then 2 is a factor of 10 because 2 divides 10. So in the same way, when I say P square is equal to 2 into Q square, it means 2 divides P square, right? 2 divides P square, right? Now, when 2 divides P square, it implies that 2 divides P also, correct? Now, when I say that 2 divides P, it means 2 is a factor of P. So, it means 2 is a factor of P. Now, see, when I say that 2 is a factor of P, it means I can write P as 2 multiply some number, say M. For example, when I say 2 is a factor of, say, 6, then I can write 6 as 2 multiply 3. So when I say 2 is a factor of p, it means I can write p as 2 multiply some number, just like here, right? So p is equal to 2 times m. Now, I will put this value of p in this equation. P square is equal to 2q square, right? So I will be getting p square means 2m whole square is equal to 2q square. Now I will open the square. 4m square is equal to 2q square. When I divide both the sides by 2, I will be getting 2m square is equal to q square. Or I can also write it as q square is equal to 2m square. Now, when I say that q square is equal to 2m square, it means 2 divides q square. Just like here, when I said that p square is equal to 2q square, so 2 divides p square. In the same way, when we are getting q square is equal to 2m square, it means that 2 divides q square. It implies that 2 divides q also, right? Now, when 2 divides q, it means 2 is a factor of q, correct? Because if a number divides another number, then it is definitely a factor of that number. Now, what are we getting here? Here we said that 2 is a factor of p, right? And here we are getting 2 is a factor of q. It means that 2 is a factor of both p and q. 2 is a factor of both p and q. It means to say that p and q are not co-prime. P and q are not co-primes. Why they cannot be co-primes? Because co-prime numbers are those numbers whose only common factor is 1. Means they are divisible by only 1. But here we are getting that 2 is the common factor of both p and q. So it means they are not co-prime, right? But here we said that p and q are co-primes. So it means this is a contradiction. So we will write that which is a contradiction. It means our supposition is wrong. Our supposition is wrong. So what we supposed actually? We supposed that root 2 is a rational number. It means we were wrong. It means root 2 is an irrational number. Hence, proved. So you see how easy it was. So hope you enjoyed the session. Thank you very much for joining the session.